This video is going to talk about how we can describe graphs. So I have my margin set up. Make sure that you put the date here. I notice some of us are writing the lines, but forgetting to put the date. So please put the date at the top of your paper, along with our topic. And then we'll put our essential question in as well. For my essential question, I've written, how can we describe the distribution of data by describing the shape of a graph? We've learned many different ways to present and describe data. We've done measures of center, we've done different types of graphs and different types of plots. Now we're going to look at some of the mathematical language that we can use to describe the shape of data. So with this video, we're going to just take a quick look at some data and see what vocabulary we can use to describe it. I'm going to set up a line plot here. So here is a line plot that shows the age that students first learn to ride a bike. And we can see a lot of different information in this, even if we don't stop to calculate any measures of center with the information. We have this part here where a lot of the data is sitting. And again, over here, we have a lot of the data as well. We call this a cluster. The name makes sense because this is where data is clustered together. A cluster can be defined as a grouping of data. This line plot has two clusters, two groups of data. In addition to a cluster, we also have this space here where there is no data. There's nothing marked here above the 9 or the 10. So for some reason, no one we surveyed in this situation learned to ride a bike at the ages of 9 or 10. We can call this a gap. In terms of math, we think of a gap as defined by an open space between data. The 9 and 10 is an open space in between two sections of data, two clusters of data. Let's look at another set of data. This time our data will show us how many times students went to go get a drink from the water fountain during the day of school. First of all, I don't see any gaps in the data. What I do see is that there's an increase as we kind of move up our number line. 3 is clearly our mode. It's the most common answer that we see here in the data. But then the numbers start to fall again. Right? This looks kind of like a mountain peak. In fact, we call this a peak. The peak here is the high point of the graph. In a graph like this, it also shows us our most popular answer, doesn't it? What if we're looking at a a line plot, and we don't see any peaks or gaps, right? Let's see what we would use to describe that type of distribution. In this quick line plot, we see this representing the number of pillows students have on their beds, right? And it just goes from 1 to 4. There's no gap, right? 1, 2, 3, and 4 all have values on them. None of them are particularly higher than the other. Sure, the 2 is a little bit higher, but it's not super significant enough that I would want to call it a peak, right? This would be what we would call uniform distribution. In uniform distribution, it's very level. It's not perfectly even, but overall there aren't too many pieces of data or values that are seen in overwhelmingly more or less amount of time than any other. We're going to look at just a couple more terms that we can use to describe data. Let me just turn my page here. In this line plot that shows the number of miles run by teachers, you might be able to describe this shape as having a peak. Right? There is a peak at 3 miles, but there's also something else that you might notice about it. There's a word that we would use to describe this shape where it's almost the same on kind of both halves. We can kind of fold it over almost perfectly on itself. Not necessarily exactly perfectly, but pretty close. Did the word symmetry come to mind? In a symmetric graph, or in this case, line plot, it's almost perfectly balanced on the left and right. There's a kind of a spot here where if we cut this down the middle, right, it would almost be the same on either side. Compare the miles run by teachers to this line plot of cookies eaten by teachers. This one is not symmetrical at all. This one we have a different term for, and that is the term skewed. When data is skewed, it means that there is more data heavily on one side than the other. In this case, it's skewed to the right because the right side, those 7 and 8s, is much higher than the left. But you could have data skewed to the left or to the right. So we were able to just go over a few terms in this video. Remember, our essential question was how we could describe data by looking at the shape of a graph. So now hopefully we have some language that we can use to describe our data.